Okay, we'll go ahead and get started.
Good afternoon, everyone. Welcome to San Francisco. Does everybody have enough fun today? Good. Looks like not loud enough. So everybody had enough coffee or not yet? More coffee? I had enough. I can speak loud. So let me go to the next slide. So I'll make sure to not want to fall in sleep in next 40 minutes, okay? If anyone is feeling sleepy, just raise a hand so that I'll stop talking. Okay? So what we are going to do in next 40 minutes, we'll walk you through our Labcorp journey with the Databricks and data platforms, where we started, how we landed with the Databricks, and also why we chosen Databricks comparing with other products available in the market. So let me start with a quick intros. I'm Mohan Kollis. I'm Director of Enterprise Analytics Platforms. I've been in IT for 23 plus years, and last 6 plus years I'm working for Labcorp as a data guy. So if someone says anything in Labcorp like an enterprise data, that's me. So Sri, go ahead.
Hi, I am Sri. I am platform architect and technical manager in data lake and data warehousing. So I have been working with Labcorp for past 6 years. So yeah, I am the data guy as well.
Malati.
Hi all, this is Malati Uppula. I am an SVP of Sales and Delivery for MSR Cosmos, implementation partner for the project.
So who we are? So how many people went to Labcorp for their lab work? Can you raise your hand if you don't mind? Okay, not many. It seems like there is something for me to take it back to my marketing team to reach more people in the world. Okay, good. I'm just joking. So Labcorp we are the world's largest reference laboratories, and our 14.9 billion revenue in 2022, and we have 80,000 employees are working in more than 100 countries around the world. So we have 2,000 plus our patient service centers in the United States, and also 6,000 plus in-office phlebotomists to help patients to collect the samples to run their tests in our labs. And we process around over 3 million patient encounters per week, which translates into tens of or hundreds of millions in a year. And we have every year we introduce the number of new tests into the market. So for example, if you see 3 years ago when the pandemic hit us, so Labcorp was the first commercial lab approved by CDC to run COVID tests in the labs. So, and also, for example, last year we launched 130 plus tests into the market. So I'll give an example of, so if you see in a flu symptom and a COVID symptom, we cannot differentiate is it a flu or COVID, right? Because the flu is kind of the seasonal, the COVID is around the clock, right? So we developed the test. By performing one test, we can sense it is it a COVID or the flu, right? And like that, we have several tests what we offer, and also we have tests from the regular chemistry test all the way to the specialty, you name it, we have it in our labs. So we offer thousands of tests. And one more thing is what I would like to say is the 90% of the FDA approved drugs, what we buy it either from prescription or the counter, those tests run through our labs before they come to us. So it's kind of proud to say, and I'm very proud to be part of a Labcorp family and working for the company and helping myself and my loved ones at the same time, surrounded by me and surrounding all of you and your loved ones as well. So the goals and objectives, why we did this one, right? I mean, last 10, maybe 10 years ago, or maybe longer than 10 years ago, we all used to hear about Hadoop. Yes, we were on the same journey. We also boarded on Hadoop 7 years ago. And then as you see, the technologies are evolving and the cloud is evolving, and the demand is growing day by day, so, and our data volume is growing day by day. So it's kind of we are not able to meet our demands, and that is the time for us to start thinking at new opportunities available in the market. Right, that's how we started our journeys. Our goal is to migrate from Hadoop to the next-gen platform, but also at the same time, how we want to build our next-gen platform for next 10 years to support our demands, right? And by considering that one, what we did, we took like, what is our current workload and the scenarios what we have in place, and also what we anticipate for the next few years, right? I cannot predict everything for the next 5 years, but at least I can foresee for next few years what features I want to build for the company. And that's how, I'm not going through the list of everyone over here, I mean, you can read it, but to highlight few things, one of the things is we want to build like a serverless architecture. And at the same time, we want to build the capability to scale vertically and horizontally. In that way, I'm not building any data platform with a limitation saying that, oh, I cannot support this, I can support this, or this is my limitation. So now the sky is the limit for me, and infinitely, I can support any workload in the cloud. And also, one of the most important feature or the struggle what we had when we were running on the Hadoop is the CRUD operations. So our 80 to 85% of the data what we get on day-to-day basis is all the relational data coming from our RDBMS or other relational systems, right? It's mostly like structured or unstructured, but the unstructured is kind of like 10 to 15% of our volume, right? So, and we always used to struggle doing the deduping, applying this CRUD operation in the Hadoop. So one of the fundamental rule for us is, okay, whatever the platform we pick it next, that should support the CRUD operation out of the box. Because I know like there are n number of solutions are available, like in a Hudi and all other tools are available, but we don't want to build the software engineering solution every time we have a need. We want to build the data engineering solution as we have the needs, right? And also, we want to always improve the SLAs, right? Because if I'm doing the same thing, what is the value I'm adding to the organization, right? If the job is running for 5 hours, I don't want to run the job for another 5 hours by getting another new platform. How can I bring it down from 5 hours to maybe 50 minutes or 5 minutes if possible, right? So that's kind of like improving the things. And at the same time, so we have some resource contention as we have like an on-prem, because you know, when you have like an on-prem infrastructure, every time you want to add like an additional capacity, can anyone guess like what does it take for us? A week, 2 months, 6? Couple of months, right? Maybe I would say around like 3 to 6 months. It depends on, if I'm lucky, 3 months, if I'm not lucky, 6 months, right? But whereas in this cloud, within few seconds, the cluster is up and running. I can put it like in a 5-node cluster or 50-node cluster. It takes the same 5 seconds or maybe 10 seconds, right? So, and also kind of, again, you can build all these cool things, but what is the stability? Can I survive on this one? Can I believe on this? Can I trust on this one? The trust is the bottom part, right? So you can build all these cool features, but if I cannot trust the solution, if I cannot trust the system, I'm not going to use it, right? Or the people are not going to use it. So that's kind of the thing is the stability and reliability is kind of the bottom line. So by considering all these things, so we went through kind of like the evaluation cycle. So what we did, so we took like I don't want to name all the products or the companies what we assess, but we took like a best of the top 4 in the market in this player in the big data space, and we went through the assessment criteria. So we prepared kind of a laundry list of the assessment criteria and the features and the capabilities of what we want to build, and we went through kind of like a rating, and then we picked Databricks is the best for us. And then we took one of our, I don't want to say complex or the simple, like a moderate use case, and then took like 3 months for us to do the POC, right? So the way I would say a simple example is, let's say I want to go to the pool for swimming. What I do first? Tip the toe. Yeah, okay, it's not that cold, okay, it's good, okay, I can jump in now, right? Whereas I jump in, what will happen? If it is 30 degrees water, it's not my body, right? And it is 70 degrees temperature. So similarly, what we do, we don't want to do like a big jump, so we want to tip the toe and feel it what we are stepping in. Is that the right thing we want to step in? Yes, that is the right thing. That's how we went through this assessment and evaluation cycle, and then finally we picked the Databricks as the platform for the Labcorp as an enterprise data platform. And the other thing is what we want to do is, I mean, like we don't want to purchase like the big money or buy the software. We want to go for like a subscription basis so that I can do the commitment for my 1 year or 2 years or 3 years and then keep like assessing as the market and trend is evolving on that one, right? And also, one of the critical thing which is I didn't mention on the slide is we want to build the solution the cloud agnostic. So today we are heavy on Databricks and AWS. I don't know, like down the line 5 years, what does it happen to the AWS, right? If AWS become our competitor, we may need to think differently, right? So that's the reason. So one of the fundamental thing is we try to avoid to build the solutions in the cloud native, which is kind of like a locking solution. So we try to build every solution what we are building on the Databricks. We try to make it as much as portable in that way with a minimal effort. Down the line, if I need to go to like an Azure or the GCP or something else, I bring it back on-prem. So we have some flexibility over there. Okay. So this is kind of like an assessment criteria. So we took it to choose our platform and landed on the Databricks. So what I would say, I would like to, from here, I would like to hand it off to my colleague Srikanth to take it like in a deep dive on the subsequent slides about our migration strategy and the implementation, how we landed. Go ahead, Sri.
So as part of pre-project planning, we have cataloged all the artifacts in the legacy system. So by looking at all the objects, by looking at all the artifacts, we have been in Spark version 1.6 and 2.4 for all our data pipeline and all the applications. So we have, so what we have decided was, so we decided to basically do a lift and, instead of doing a lift and shift, we decided to go and rewrite all these applications to utilize the Databricks, to reap the benefits of the Databricks as well as for cost optimization, improve the cost optimizations and to improve the SLAs. So all these cataloged objects, we have cataloged all the objects, and when we looked at all our objects, we were seeing there were several objects which were more like bringing the data into the platform using Flume, Scoop, and via using other ETL products. There were some objects we have categorized into inbound, and we have several batch processing jobs. So, and we categorize them into batch processing, and then we have categorized into the outbound, which is like ETL, and we have used the ETL as well as the like Scoop and all to, not the Scoop. We have used the ETL and some custom applications where we have sent the data out of the platform. So once we categorized all these objects, we have built generic, we decided to build generic frameworks so that we can address multiple objects instead of dealing with one artifact at a time. So we have built the generic framework for inbound processes where we were using Scoop and Flume. We built a generic data framework. Similarly, we have built several generic frameworks which will be going in detail, and we will be seeing a live demo as well on those objects. So as part of this project, so once we catalog these objects, we basically, we had small groups. We went with an agile approach. We identified our partners, and then we have small groups who started working on those objects. So this is our architecture. So we have 3 workspaces, one for dev, stage, and production. We have enabled the private link, and we have the back-end and the front-end private links implemented. So our data can be accessible only within the VPN, not accessible outside of our VPN. So from the user authentication perspective, we have enabled Okta. So all this infrastructure we have built using Terraform scripts. So that way we could scale and easier to maintain and manage it. Our CI/CD pipelines, for the code repository, we use Bitbucket and Jenkins, and IBM Urban Code Deploy for deployments. So as part of the first design decision, what we have done is all our access we decided to control at the schema level rather than controlling at a table level. That was the first design decision we have taken. Now, if we go from the bottom up, so we have 3 catalogs. So one is the presentation layer catalog, integration layer catalog, and the raw layer catalog. So like we organized all the data within these 3 catalogs, and as we hear about medallion architecture, all the bronze data resides in the raw layer. The schema exists. Okay. The battery died. I don't know.
System is restarting. Oh, looks like system got bounced. Maybe, yeah. Okay. Sorry about the interruption, so just give us a minute.
Why is it saying that?
Wow.
No, I did not.
Looks like auto went off.
So at least speaking through it, right? So at the bottom layer, we have seen the catalogs. So the data is organized in the catalog. The raw layer has all the bronze data. The integration layer has all the silver tables, with an exception of any tables that should not be accessed by the end users are placed in the silver tables. In the presentation layer, we store all the gold tables and some silver tables, which an end user can access it. So the next level is the technical groups. We have 6 technical groups and 2 technical groups per catalog. So the 2 technical groups per catalog, and each technical group, so the first technical group has read-write access to the catalog. The second technical group has read-only access to the catalog. So these are the technical groups that we are talking about. One has read-write access to this catalog. The other one has read access to the catalog. So these technical groups are assigned to the functional groups, where the functional group, we have all our users are classified into developers, job users, QA and BA, and reporting. So developers has read and write access in the development environment for all these 3 catalogs, but he has only read access in the stage and the production environments. So similarly, the BA QA has only read access to all these catalogs. Job user has read-write access to all these catalogs. And reporting user has read-only access only to the presentation layer, because integration layer and raw layer data is irrelevant to them, and it's not data quality checked or anything, more for technical users. So we got this functional groups. The functional groups are assigned to the workspaces, so that workspaces can access the functional groups. The functional groups, users are assigned to the functional groups. And scopes, entitlements, technical groups, instance profile, cluster policies, and SQL warehouses are all assigned to the functional group. So that once you assign the functional group, all these accesses are controlled via the functional group. So very simplified access mechanism. Now we'll jump into, all the slides will have a demo at the end. So Spark structure streaming. So we used to get a lot of data from Kafka topics and Kinesis streams into the Hadoop platform. So we used to get it into the platform using Flume by using some configurations. So in Databricks, the alternative was to use Spark structure streaming. So that's where we built this generic framework similar to Flume. So where we could configure the source topics, the host details, as well as the target table names. That way, the data is resided into the Delta tables. This is the generic framework that we built. We'll have a demo shortly. Batch processing. So in our Hadoop environment, so there were several batch processing applications which were built over a period of time by several developers. There was no consistent pattern when team members were building this stuff over these years. So it was very hard to manage them, even if a developer wants to go and enhance or to support it, it was very challenging. So we came up with a generic design pattern such that an end user, such that any developer would be able to easily manage this solution. So what we have done is, at the very end of the slide at the top right, so we have a table, which is the metadata table. The metadata table stores file path, more of a metadata information. It stores the file path, the bronze delta table information, like the catalog, the schema, and the table name. Similarly, the silver delta table information and the gold delta table information. In a denormalized fashion, all this information is stored in a metadata table. And we have this orchestrator. Orchestrator is a very small job that runs in Databricks. It's a very small node that we utilize. Basically, what its purpose is to check whether the files have arrived. So it can run via file trigger. Some of the applications runs via file trigger, or some of them runs via schedule basis. Its steps is go to the S3 file path, read the files, get the list of the files, check if all the files have arrived. For us, it's like 3 files should arrive. If all these 3 files has arrived, then combine that information with the metadata information, basically join these 2 informations so that you finally get something like an audit log table, which has the run date, the file date, and all this metadata information. And then the orchestrator, once it builds all this data, it goes and triggers the job which is the main job, which you look on the very bottom. It goes and triggers the job. Every step of the job, from S3 to raw to bronze and silver, every step of the job, the first step would be to look at this audit log table and see whether this information has already been processed or not. If it has not processed that particular step, it runs through the step. If it has already, once it completes the step, it goes and updates that audit log table with the time when the step has ended, and even the total counts. That's why every step of the process knows that the previous step has completed, and it can run that current step, and then updates the audit level information. If in case for any reasons, if the job has failed, once you restart the job, even not restart the step, you can restart the job, it will immediately get into that step which it needs to run. So we built again a generic framework, generic application to read the data from databases and to read the data from Golden Gate. Golden Gate basically replicates and writes the data into the S3 bucket. So we have implemented the autoloader, which can read both the full load and the incremental load and write the data into the platform. Similarly, for all this master, transactional, and reference data, we can read it via JDBC, Spark JDBC, either Spark JDBC or autoloader. We have used both in this case. So using Spark JDBC, we can read the data and write it into the goal table. Again, we built this process in much more configurable fashion so that we can configure multiple databases and tables, and it can bring the data into the platform. So the primary tables over there are like table config. Table config stores the information about what is my source table name, my source host names, and secret scopes, and the target table names. And column mapping is more about what is my source to column mapping, and source partitions config table is like, it gives the details about the source partitions in the source databases so that we can, using the Spark JDBC predicates, we can send multiple predicates to the backend and run the data in parallel to retrieve the data in parallel. And dynamic transformations are more like we can apply the trim functions or any other functions on top of this data once we pull it out. So data compare, again, this is one of the best designs that at least for this project that we have implemented. So one of the biggest challenge anyone who goes with this migration project is, or the time consumption that takes for data validations is more of this data validations takes a lot of time to validate all the data. And even for our business users, it is a challenging thing to go and validate and give a sign off that, yeah, everything looks good. So for that purpose, what we have done is we have implemented this data comparison tool, which takes the source data and which takes the target data and compares both at a record level and even at a cell level and split out the differences so that we were able to compare 99.9% of all our data from Hadoop to Databricks. And from the QA perspective and all, it was very simplified in that fashion. Even that improved the overall project time itself. So how we have done is, so we have a JSON which has both the source and the target columns. It has the table details, the source and the target column details in a JSON. Basically, once we pull the data from the source as a data frame, we replace the nulls with spaces, we trim the spaces, and the source data frame data, all the columns, we rename them into left underscore, the column name. All the target, we rename them into right underscore column name. We have now we have two data frames, source and the target. So at the bottom portion, we do an outer join in the code. We do an outer join so that it combines both these data sets into one data frame. And then we do an map partitions so that it goes at an RDD level and we can iterate record by record. Once it goes to record by record, we take a record, we convert it into a dictionary. Once we convert into a dictionary, we again split it into two, the left and the right, based on the column names. And then we go and compare the left value with the right value. If we find a difference, then we basically write it into a data frame, write it into a list, which comes out as a data frame as data errors. So that way, we were able to compare millions of records with 100% match with the data. If we have any issues, we were able to find all those issues. Even our developers were using this tool to go and compare all this data. So
I would say this is kind of a secret sauce for us to complete the migration from Hadoop to the Databricks within 6 months. And just to call it out, our data size is close to a petabyte. so around 950 terabyte, that's what we migrated. And one thing is I would like to say, if anyone is looking for the migration, one tip I would offer is, in the Hadoop side, there is no concept of like a null, it's always kind of the space. And most of the things what we found, so it's kind of adding like a leading or trailing spaces, which we cannot see, but the system is detecting. When you're comparing the source and targets, we are always finding the differences. But what are the differences? Additional spaces. So that's what we started doing kind of the trimming on both source and target, so that we are comparing like an apple to apple. So it is kind of that's kind of almost, we spend around 20% of our testing cycles on trimming on the spaces on the rest in the different columns. So if anybody is trying to look for a kind of an automation, so I would say that, okay, find this kind of, another thing is kind of the timestamps, because in the Hadoop world, there is no timestamp, it's always kind of the string, and it have a different timestamps. When you're coming to a Databricks, we have the timestamp. When you're comparing these two, they're not liking. So you had to do some kind of a cook-up thing on the source side as you're reading the file, translate into kind of a timestamp, and then compare so that you're comparing the value.
Quick walkthrough of Unity catalog creation process in Terraform. All the administrative activities are done in Terraform except user authorization assignments. Using this approach, we can scale schema creation process. So I will walk through how we have organized our Terraform project. We have 3 modules. The primary module is the common module. We have a project and we have a sandbox module. Project module is used for schema creation process. Common module is the parent module, which calls the child modules project and sandbox. Common module is used for catalog creation by calling this submodules. Scopes, instance profiles, IAM policies all are created using the common module. Our primary focus is going to be on project module. So in the common module, we are using providers like Databricks and AWS. So we use Databricks Workspace and the Databricks accounts providers. So in our sub-module, we are saying our required providers are Databricks and the configuration aliases which are processed from the parent module are Databricks, MWS and Databricks. In common module, we call the submodule by providing the schema name and external locations for the schema. The providers needs to be passed from the parent module to the submodule. Going into the project module schema create.
So let me give a pause. So whenever we create the projects, right, whenever we create the new schemas, we want to scale it. Right? In this case, we want to scale it faster. If a new project starts, yeah, you need some schemas for it. We want to scale it. How are we adding the new schemas to what we have I explained earlier for the Unity catalog? This is how we are doing it, right? So we take this template, we basically replace the schema name with the new schema name, whatever the new schema name is, and whatever the external locations that we have the data, the landing zone data or the parking zone or any outbound if you are writing it. So we maintain all the external locations. We are basically mentioning all the external locations over here. So this way, in just few minutes, I can create a schema and prepare the whole governance model, security model on top of it. So this is how we are doing it.
Process the very step.
So let me go through faster. So the very first script is the technical user group. The way we discussed, right? The technical user groups are there. Now we are kind of creating the schemas. So the way we explained earlier, we have 3 catalogs. That's why we are creating 3 schemas in all the 3 catalogs. And we are assigning the grants over there. So the grant is like an admin will have the privileges. And again, the technical groups, based on the technical groups, either they have the S full or the full access or the read access. And then we are going to the functional users. We are creating the developer user over here. In the developer user, we are basically going and assigning. In this case, we created the developer user, and we are going and assigning all the schema access, where either he gets a full access or not. That's what we are mentioning over here. We are granting the access. We are giving the technical user, which we created earlier, we are assigning it to it. So that way, the functional user has the full access to go and read and write the data. So we added an audit log. So every user, we give an audit log. So in here, what we are doing is we have the stage environment, stage and production environment, where a technical user will get only the read access. So similarly, we got the job user. We have the BA user. For the BA user, we are giving only the read access, nothing else, for all the catalogs. We got the functional reporting user, where we are giving the read access only to the presentation layer, not other layers. And we are assigning these roles to the workspaces, because these are functional users. This role should be visible or available in the workspaces. We are basically doing the assignment to the workspace. Entitlements is more of, can they use the SQL workbench, or can they use both the workspaces and the SQL workbench? Those are the entitlements that we are adding it over here.
Time check.
So external paths, the way I mentioned earlier, so we are giving the external paths access. So let me go to the end. So these are all the REST services that are available, so that an administrator, if you go and ask administrator, what access does this X user has access to? Like either the entitlements or the technical roles, all those details, this REST API can provide that. So what we have done is we have used this REST API, and we went and created basically all the tables so that he can easily query it. So now we are going to the batch processing. We have an orchestrator. The way I have mentioned, it's a very small node. We run it on a very small node. And we got the TAD daily process, which is like our main process itself. So the orchestrator, in the very first step, we go and browse the landing zone. We basically get all the files, and we create a data frame out of it. So that is the data frame with the run date, the file path, and the join key is just a join key to join between the two tables. Over here, we are checking whether we have processed these files before or not. If we have processed the files, it will not go to the next step. If we have not processed these files, this is the first time we are processing it, then it will go to the next step. So below we got below we have the TAD metadata table. So this table is the one which we were talking about, the metadata, which has information about our paths, where our data is getting stored, our bronze tables, the silver tables, and the rest of the things over there.
Just read time, 1 minute. You can skip the video.
So over here, we are joining both the tables. That way, we can send this information. We can use this table information, and we call the main process. The main process will be querying all this information. So over here, we are checking whether we have received all the 3 files or not, and we call the main process. So it calls this main process, and in the main process, we are using that table to basically check whether we have processed the previous step or we haven't processed the previous step. If we have processed the previous step, then it goes into the step, it processes that particular, either it's a transformation or parsing of the information or any of the things, right? And finally, it goes and updates this metadata table saying that I have completed this step.
So I know there is a lot more to cover. Sorry if you're running out of the time. So maybe you'd like to open for questions.